Okay, for do now number 7, we're going to review simplifying radicals and adding radicals. So first, let's do number 1 for 2 radical 48. Again, when you're simplifying a radical, you're looking for the biggest perfect square that's a factor of that number. So the biggest perfect square that's a factor of 48 is 16. So I'll do 2 times radical 16. And again, if you do 48 divided by 16, you're going to get an answer of 3. Again, you haven't taken the square root of anything yet, so both those are still underneath the Rudy house, but now I can take the square root of 16. The square root of 16 is 4, so I'm going to have 2 times 4 times radical 3. And again, the last thing that we can do is multiply the 2 times 4. 2 times 4 is 8. So 8 radical 3 is going to be your final answer there. Again, you can't actually multiply the 8 and the radical 3. You can't multiply a number that's outside the Rudy house by a number that's inside the Rudy house. For number 2, in order to add radicals together, you have to have, again, what's called like radicals. Like radicals means, again, that you have to have the same exact number underneath the Rudy house. Again, it's always easier to simplify the smaller radical first, so let's start with radical 24. The perfect square that's a factor of radical 24 is going to be radical 4. And if I do 24 divided by 4, I'm going to get an answer of 6. So radical 24 is going to break down into radical 4 times radical 6. If I'm going to eventually be able to combine these two, I'm not going to be able to take the square root of 6. So 6 should be a factor of 54. So if I take 54 and divide it by 6, I'm going to get an answer of 9. And 9, again, is a perfect square, so that's going to work. So we're going to break down that radical 54 into radical 9 times radical 6. And again, I'll take the square root of my perfect square, so I'll take the square root of 9 and the square root of 4. The square root of 9 is 3, so I'll have 3 radical 6, and the square root of 4 is 2, so I'll have 2 radical 6. Now I have like radicals. They have the same number underneath the Rudy house, and remember, when we're adding like radicals, we're treating the radical like we would a variable. So if we were to add 3x plus 2x, our answer would be 5x. So when I add here, I'm just adding the 3 plus 2, it's 5, and I'm tacking on that radical 6. That radical does not change. So 1-7 is going to be about midpoint and distance formulas. So what is a midpoint? Again, a midpoint is going to be the point that is in the center of the line that divides the line into 2 equal pieces. So when we're talking about the coordinate plane and ordered pairs, we have what's called the midpoint formula. And the midpoint formula is m equals x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Okay, again, we're talking about ordered pairs here, x comma y. Okay, again, it always comes in that order, and it does not matter which one that you call x1 and y1 and which one you call x2 and y2. Just make sure that your 1's stay together and your 2's stay together. I'm a creature of habit. Every single time I do a problem, I always call my first ordered pair x1, y1 and my second ordered pair x2, y2, just to be consistent. So, for example, number 1, EF has endpoints of 7, 5, and 2, negative 4. What are the coordinates of his midpoint? So again, I'll call this x1, y1, and I'll call this x2, y2. Now, you do need to memorize this formula, only because I didn't leave myself a lot of space in here. If I were you, and you're doing this, every time you use that formula, you should rewrite it, because you're not going to be given that formula on a test. You need to memorize it. But just because of space, I'm not going to rewrite it right now. So I'm going to replace my x1 and my x2 with the 7 and the 2, and I'll replace my x2 and my y2 with my y1 and my y2 with my 5 and my negative 4. So x1 is 7, x2 is 2, so I'm going to have on the top there 7 plus 2, and we'll divide that by 2. And for my y's, I'm going to have 5 plus negative 4, and divide that by 2. Okay, let's stick with this left-hand one. That 7 plus 2 will give me an answer of 9, so I'll do 9 divided by 2. And for the right-hand one, 5 plus negative 4 will give me 1, and I'll have 1 divided by 2. And again, I'll go ahead and divide each one here. 9 divided by 2 is going to give me an answer of 4.5. And 1 divided by 2 is going to give me an answer of 0.5. So my midpoint here is 4.5 and then 0.5. For number 2, I want to find the midpoint of AB, and the coordinates of A are 3, -1, and the coordinates of B are 2, -7. So I scrolled past that midpoint formula. Let me try to write outside the margin a little bit, and I'll rewrite that formula and we'll reuse it. So it's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Again, creature of habit, I always call my first ordered pair x1, y1, and my second one x2, y2. So let's go ahead and replace those. So x1 is 3, so I'm going to have 3 plus 2 divided by not 5. Let me get rid of that. I'm going to have 3 plus 2 divided by 2. 3 plus 2 is 5. That's why I wrote that. And y1 is going to be -1 plus y2 is -7. And again, we'll divide that by 2. So 3 plus 2 is 5. So we'll have 5 divided by 2. And -1 plus -7 is -8. And we'll have -8 divided by 2. 5 divided by 2 will give me an answer of 2.5. So my x-coordinate of my midpoint is going to be 2.5. And my y-coordinate -8 divided by 2 will give me a -4. So 2.5, -4 is going to be my midpoint there. Another thing that you can do besides using that formula is you can end up using a graph grid in order to find the coordinates. So it says the midpoint of CD is M, which is -2, 1, and one of the endpoints is C, which is -5, 7. And we want to know what the coordinates of the other endpoint are. Again, I know it's kind of hard to understand this from the video, but I'll try to show you using the graph grid, and I'll also show you doing it algebraically. So our midpoint is -2, 1. So that's there. So that's the midpoint. And my other point is going to be -5, 7, which is going to be up here, and that's C. And we want to find the coordinates of D. In order to do that, all I'm going to do is count how far I have to go down and then how far I have to go to the right to get to M. And then I'm going to repeat that same pattern and start at M and go down the same number of boxes and to the right the same number of boxes. So to get from up to C down to here, I'd have to move down 1, 2, 3, 4, 5, 6. So I went down 6 and to the right 1, 2, 3. So I went down 6 and to the right 3. So we're going to start that same pattern starting at M. I'm going to go down 6, 1, 2, 3, 4, 5, 6, and then to the right 3, 1, 2, 3. And there is my point D. But again, doesn't really matter that I graphed that so beautifully. They want to know what the coordinates are, so I do need to state what those are as an ordered pair. And as an ordered pair, that is going to be the point 1, -5. Okay, so I can also look at this algebraically and use the midpoint formula like we did in the last two problems. So I'm going to call C my x1 and my y1. Well, that's great, Miss Kudak, but you just said we always call the first ordered pair x1, y1. Can't in this case, because in this case, they gave you the midpoint. So that's not my x1 or my y1 or my x2 or my y2. That's the midpoint. So I had to use this as the C as x1, y1. Okay, and now what I'm doing is I'm looking for x2, y2. So just to make it not so messy, when I am putting x2 and y2 into the midpoint formula above, I am going to ignore the little 2 there and the little 2 there. So the midpoint formula, again, if we come back up, it's there. I won't rewrite it again to try to keep this a little bit neater. I'm going to take x1, and to that I'm going to add x2. x1 is -5, and to that I want to add x2, which we just decided was x, and we're going to divide that by 2. But now I know what my answer is when I do that, because I know what the coordinates of the midpoint are. The x-coordinate of the midpoint is 2, so negative 2, sorry. So when I do that, I have to get an answer of negative 2. And now all I'm going to do is solve that simple equation. The opposite of dividing by 2 is to multiply by 2. So if I multiply both sides by 2, those 2's will cancel, leaving me with negative 5 plus x. And on the right, negative 2 times a positive 2 is a negative 4. And now I'll add 5 to both sides. And x is going to equal 1. And notice over here, we had gotten x equals 1 when we did it on the graph. And now we'll do the same thing with our y coordinates. So for our y coordinates, again, we're going to take y1, which we found out was 7, and add y2, which we're calling y, divided by 2. And again, I know what I get when I do that, because I was told what the value of the midpoint was. It's 1. So that's going to give me 1. And again, we'll solve. Multiply both sides by 2. So the 2's will cancel on the left, leaving you with 7 plus y. And on the right, 2 times 1 will be 2. To get rid of that positive 7, we'll subtract 7 from both sides, and 2 minus 7 will give you an answer of negative 5. And again, when I look over here, that's what I had gotten when I used the graph grid. So 1, negative 5 is my solution there. I have 2 dogs that are very unhappy right now. There's people in my yard doing work. I apologize. Okay, the distance formula is another formula that we're going to need to memorize. Okay, and the distance formula is going to find the length or the distance between 2 points. And again, we're still going to keep talking about this x1, y1, x2, y2. Okay, so the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. So for number 4, we want to know what the length of AB is, and we want that in simplest radical form. So again, we'll bring in our simplifying radicals from that last section. Okay, well, the first thing that I need to know is I need to know what A, and B are as ordered pairs. So if I count to get to A as an ordered pair, A is going to be the point negative 3, negative 4. And again, if I count over to get to B, I'll have to go to the right 4 and up 3. So as an ordered pair, that is going to be 4, 3. Okay, again, just because of space, I am not going to rewrite the distance formula, but you do need to memorize that formula. So every time you use it, you should rewrite it, because the more times that you rewrite it, the more likely you are to remember it. Okay, so distance, again, it's x1 minus x2, y1 minus y2. So let's label our x1s and our y1s. So this is going to be x1, y1. X1, y1, x2, y2. Okay, so distance is going to be the square root x1, a number that's above x1 is a negative 3, minus from the formula, and then x2 is 4. So I'm going to have negative 3 minus 4. I'll bring down the plus sign from the formula, and then we're going to have y1 minus y2. y1 is negative 4. We have a minus sign from the formula, and y2 is 3. So, and we need to square that. So now we need to simplify everything that's underneath that square root symbol before we can start talking about simplifying that square root. So the first thing that we're going to do is simplify we have to follow order of operations. So we're going to do what's inside the parentheses first. So I'm going to have negative 3 minus 4 is going to be negative 7. So you're going to have negative 7 squared. And negative 4 minus 3 is going to be a negative 1. And we need to square that. And again, simplifying underneath there, negative 7 squared is going to give me a positive 49. and -1 squared is going to give me a +1. If you're using your calculator to square something, just like I wrote those parentheses, please make sure that you are putting your number in parentheses just like I wrote it, or else your calculator is going to give you a wrong answer. When you square a negative number, it's a negative times a negative. A negative times a negative is always a positive. So you should not get a negative answer for this number or this number. Okay, and now when I add 49 plus 1, I'm going to get the square root of 50. Okay, so that's the answer in radical form, but again, it did not ask me to find that answer in radical form. It asked me for it in simplest radical form. So I have to find a perfect square that is a factor of 50, and that is going to be 25. So I'm going to have radical 25 times radical 2, which is going to be 5 radical 2. I made a math error in there. Boy, oh boy, oh boy. I don't want to stop this video. Because I don't know how to subtract, because I'm trying to do this all in my head at the same time. I have a math error right here. -4 minus 3 is not -1. So, bear with me. I really don't want to start this video all over again. I do apologize. We'll get rid of that and we'll redo from underneath that. Okay. Let's try this one more time. Let's see if I can get my subtraction right this time. Okay, so -3 minus 4 is going to give me an answer of -7. So I'm going to have -7 squared plus, and when I go to the other side, -4 minus 3 is also -7. It is not -1. And again, make sure you bring down those squareds. And again, when I square them, I'm going to get positive answers. So 7 squared is 49. 7 squared is 49. Again, we have to simplify everything as much as we can underneath that Rudy house before we simplify. So radical 49 plus radical 49 is going to give me radical 98. Again, that's in radical form. We need it in simplest radical form. So we need to find a perfect square that's a factor of 98. You can kind of cheat. If you look back here, we had 49 2 times. So I'm pretty sure that 49 is going to be a factor of 98. So if you take 98 and divide it by 49, it does go in evenly, and it goes in evenly twice. So I'm going to break down into the square root of 49 times the square root of 2. The square root of 49 is 7. And again, I'll bring over that radical 2. Next one for number 5, we want to know the distance between -6, 5 and 4, -3. And again, we want our answer in simplest radical form. And these dogs, this whole video, I apologize. Okay, so let's write the distance formula. The distance formula one more time is x1 minus x2 squared plus y1 minus y2 squared. And again, I'll label my first ordered pair x1, y1, and my second ordered pair x2, y2. And now we will plug that in. So x1 is -6. And from that, we're going to subtract x2, which is 4. And then we'll square that. And then y1 is 5. Minus y2 is a -3. So again, you have a minus sign from the formula, and then we're subtracting 3. So it's going to be a double negative. Okay, and now again, as I continue to simplify under there, inside the parentheses, we'll do -6 minus 4 first. -6 minus 4 will give me an answer of -10. So I'm going to have -10 squared. And on that right-hand side, this double negative is going to become a positive. So 5 plus 3 will give me 8, and I need to square that. So 10 squared will give me 100, and 8 squared will give me 64. Again, got to simplify as much as possible before we try to take the square root of anything. And when I add 164, I'm going to get 164. Okay, now our goal is to find a perfect square that is a factor of 164. There's only one that's a factor of it, and it's one of the smaller ones. It's actually 4. So 4 is the only perfect square that's a factor of 164. So we'll break that down into radical 4. So if you do 161 divided by 4, you should get an answer of 41. So it'll break down into radical 4 times radical 41. And again, when I take the square root of 4, it will give me 2. So we're going to have 2 radical 41 as our answer there. Okay, and our last problem, let's see if we can get through it without my dogs barking. We have the length of R, we want to know what the length of RS is if the coordinates of R are 1, 2, and S is negative 4, 6. And this time we couldn't. So S is going to be negative 4, 6. So again, x1, y1, x2, y2. So again, I'm not going to rewrite the distance formula just because I'm running out of room here. So it's right above. So again, we're going to have x1 is 1. We have a minus sign from the formula. x2 is negative 4. So we're going to have 1 minus negative 4 squared plus y1 is 2 minus y2 is 6. And again, I need to square that. Again, this double negative in the first set is going to become a positive, and 1 plus 4 will give me 5. So I'm going to have 5 squared there. And on the other side, 2 minus 6 is going to give me an answer of negative 4, and we're going to square that. So now I'll square both those numbers. So 5 squared is 25, 4 squared is 16. So 25 plus 16 is going to equal 41, so I have the square root of 41. And now you're going to go into your calculator and hit second, and then the square root, which is on that left-hand column. Look for that square root key. Should be in yellow if you have a TI-83, and if it had the TI-84, it might be in that bluish color, but it is on that left-hand side about halfway down. Okay, and then when you put that into the calculator, rounding to the nearest tenth, that's 1 spot after the decimal, you should get an answer of 6.1.